expect you to ask, you talked about this parametric form and you introduced the curve. The question is, how do you find the rate of change for parametric curves? How to find the rate of change for parametric curves. Why we are interested in that? Remember that. Because in elementary calculus, we learned that if we have y equals to f of x, we can find the equation of tangent line at a point, at a number. Of tangent line. Point like A and B is, let's write at x equals to A. I don't want you to get confused. Is y equals to f prime at A times x plus B. This is equation of tangent line by taking the derivative of the function and plug in A. So naturally, we expect to write equation of tangent line for parametric curves. Okay, well, here you have two cases, two situations. In case one, we are able to get rid of variable t, write y in terms of x. So sometimes it is easy to get rid of t, the parameter, and write a function and write y equals to f of x, then follow what you learned before. Sometimes it's easy to do that. Sometimes it's easy to isolate your y on one side and you don't have any t to worry about. Then at x equals to a, equation of tangent line is y equals to f prime a times x plus b. Tangent line. Some other times, it's very hard to get rid of t. We have to have everything in terms of t. So in second case, case 2, sometimes we cannot get rid of t. So in this case, we need to know how to find the derivative of the parametric equation. So in this case, y prime, which is equal to dy over dx, is equal to taking the derivative of y with respect to t, dy dt, the derivative of y with respect to t, divided by dx dt. In this case, we need to plug in the values and find the rate of change, then follow the formula for tangent line. So what we presented here, the derivative of parametric equation y prime, which is dy dt divided by dx dt. We take the derivative of y with respect to t, we take the derivative of x with respect to t, we divide these two. So let me write down the formula here for you. So let y be f of t. And let me just follow the note. Okay, x is equal to f of t, and y is equal to g of t. Then the derivative is equal to, we take the derivative of y with respect to t, so we have g prime divided by the derivative of x with respect to t, which is f prime of t. Over one example for you. So you see what I'm talking about. Example. So suppose we have this parametric equations, x is equal to t squared, and y is equal to t cubed minus 3t. Question says, show that the curve has two tangents. Show that the curve has two tangents at the point 3 and 0. 3 and 0. Let's answer part A for now, then we write part B. Well, what are we looking for? We're looking for tangent lines. Well, we need to write the equation of tangent lines. So how do we write the equation of tangent lines? We need to find the derivative of these parametric curves. You might say, hey, I want to write x in terms of y or y in terms of x. If you want to do that, t is equal to square root of x plus minus, then you have to type plus square root minus square root. You get two equations for your y. It gets a little bit complicated. You have to deal with square root, raise square root to the third power, and so on. Well, I'm going to follow the formula that we learned today. It seems like it's much more easier, less complicated. So since we are looking for the tangent lines at x equals to 3, we need to take the derivative. Well, I know that the derivative is equal to the derivative of y with respect to t. So I'm going to take the derivative of t cubed minus 3t with respect to t divided by the derivative of x with respect